Welcome to our RDS sessions. Today we are going to see the Amazon Web Services RDS service in detail. We are going to see where RDS fits in and what are the other different features of RDS and how we can use them. So that's about me, and let's just move forward and see what are the topics we are going to cover. We are going to briefly cover what is RDS, what is DynamoDB, what is the difference, and where does the Elasticache come and sit in here, and when to use them, the common use cases where all people are using RDS, and finally we are going to do a hands-on demo with using RDS MySQL database. So let's go ahead and see where that fits in. RDS is part of the database as a service that Amazon offers along with the DynamoDB and Elasticache. It supports multiple database engines, so we are going to spend a lot of time understanding how RDS is different from other databases as a service in the market and why it is growing so popular and why people are using it. So those are the things that we are going to see today. So RDS is easy to set up a database which can operate at a scale, and it is a relational database that Amazon offers. There are two types of databases available in the market. One is a relational database, and another one is a no relation database, that is a NoSQL as it is usually called. RDS falls into the relational database or SQL database that you can easily refer to. It supports multiple engines, and it can handle and it can takes out the administrative tasks like taking a backup, upgrading the operating system, making a replica, making a slave. All those things are automated, or most of these things are automated using the console itself by Amazon. So the amount of effort an admin has to do with an RDS is very limited, so that they spend more time on creating the data schema or the data model for their architecture. So that is how RDS is different, and it is releases the people or the human effort from doing mundane tasks like taking snapshots 3 times a day or 6 times a week. You can automate those tasks and ensure that RDS takes care of the remaining things. Just so there are multiple features of why we need to choose RDS. We are going to see some of them right now. RDS is very simple to use because the console takes care of most of the tasks, like whether you want to set RDS in a multiple availability zones, or you want to set it up in a single availability zone, the type of engine that you want to use, whether you want to run a MySQL engine or a Postgres, MariaDB, Aurora, or anything. And most of these functionalities are different design decisions that you in a conventional architecture it takes a lot of time. Here is a simple click away, so it is relatively easy for anybody to go ahead and start using a database in their cloud services, and it is cost effective when compared to some of the other databases, conventional databases you can run on your on-premise infrastructure. RDS is comparatively cost effective because setting up a cluster which can scale across two data centers is very difficult in a conventional data center, because the high availability and scaling and synchronous replication, all these things comes with a very high cost and a very high skill database knowledge. And the cost and the skill knowledge eats into the infrastructure and the skill level eats into the cost of setting up such an highly available database. So when compared to that, RDS gives you a simple click away multi-availability zone database. That is, RDS is capable of spanning across multiple availability zones very easily. It is just a checkbox that you just choose it, saying that it has to be a multi-AZ deployment. So the cost comparison will be straightforward in my opinion. So it is very effective to choose RDS over an on-prem database. And security wise, all the security that you employ in a VPC gets carried forward to your RDS. You can have a separate security group for your database layer. You can have a separate subnet for your RDS instances. And in addition to that, or on top of that, you can enable encryption by a checkbox, just like we do for EBS. You can encrypt your database by using the checkbox. And there are other parameters also. For example, the DB parameters, like for user ID, you can be completely customized to you. You can use an IAM role so that other instances are not talking to a database using user IDs. Instead, they are using an IAM role. So nowhere your applications have your database user ID and password hard coded. So there are multiple ways you can secure your database by using RDS. I've just given some of them. And in fact, if you remember, I spoke about upgrading your database automatically, because Amazon takes care of, or owns the responsibility of upgrading your database. You just have to inform Amazon what is the downtime, that preferred downtime for you. Then Amazon will upgrade your database whenever it is convenient for you. And upgrade, or ensuring the upgrade is successful, is on Amazon's responsibility, and they take care of that. So why I'm talking about upgrade is that sometimes some older versions of databases have some vulnerability, or in other words, any older piece of code, eventually any vulnerability is found out there, and people try to exploit those vulnerabilities. So it is necessary to upgrade your database or patch your database to the latest versions and keep it secure. So when Amazon takes care of or owns that responsibility, it increases the security of your database as well. And since we have seen already EBS volumes have a concept of provisioned IOPS or throughput. So likewise, you can also have a similar concept carried forward to RDS also. If you want a certain amount of IO throughput from your database, you can provision the underlying disks for that IO throughput. So you can have predictable performance when you're running your applications. You can do a load test and find out what is their expected performance, and you can set your disks for that level of provisioned IOPS, PIOPS as it is called usually. So another important feature is scaling to demand. You can vertically scale your RDS instances by choosing the underlying instance, whether it is T2 micro or going all the way to X1 large. So the scaling is possible vertically. And when it comes to horizontal scaling, you have options of creating multiple read replicas or slave servers. So that is how you scale your servers, both vertical and as well as horizontal. And when it comes to durability, this database is built on top of EBS disks, and EBS is indirectly built on S3. So you can understand that the durability is carried from all the way from S3 to EBS, and EBS we know that gives about 5 nines of availability and durabilities. So your RDS instances are going to be highly available. You don't have to worry about your RDS instances failing on you. You don't have to create any RAID or a rack cluster or those kind of additional layers on top of your RDS itself. So RDS comes built in with these kind of durable features. And RDS has an endpoint. That means that it is just a URL endpoint, so you can connect it from most of your applications without any problems. And there are RDS connectors available in Java or most familiar languages. So just your JDBC connector is more than enough to talk to your RDS instance. You don't have to write any specific connectors to work with RDS, because the engines are all common and the connectors are also the same way. So it works out of the box with most of your applications. No additional coding or customization is required to use an RDS. Finally, no administrative task. Instead of saying no administrative task, you can say most of your administrative tasks are automated here by taking backups, upgrading, patching, fine-tuning your performance, or most of those things have been taken away from the administrator itself, and it is taken care by Amazon itself. And finally, on the right-hand side, you see the different engines that are supported. The MariaDB and MySQL are more or less the same engine, whereas MariaDB is the Oracle-owned MySQL engine, whereas the open source community has forked MySQL and they are retaining the brand name as, Oracle owns the MySQL brand name and MariaDB is the open source version of the same. So it is more or less the same engine, and the differences are, as of now, until the current version, the differences are very, very minimal between these two engines. But there are discussions that in the next version, the differences might diverge, where they might not be compatible to each other, or you will need an additional plugin to move data from one engine to another engine. The reason for you to know that is sometimes people are moving from MySQL to MariaDB because Oracle is not constantly upgrading MySQL, and Oracle owns this rights for this logo and this branding, and it is not updated as fast as an Oracle is itself is updated. That is Oracle database. So people are trying to move away before the differences are too much. So some migration activities that happening in this area in the market. Let's move forward. RDS is this is a typical RDS setup. An RDS instance is DB instances are the building blocks of RDS. That is, you have a T2 instance or a micro or X4 or D1. Those kind of underlying instances forms the building block of your RDS, and they can be you can create multiple databases. It is not that you create an RDS instance and there is only one database has to be inside it. You can have multiple databases inside the same instance, and they are all in an isolated environment in the cloud, so nobody else can see it what you are running. Remember, I spoke about VPCs. So any resource inside your VPC, unless you provide access to any third party, they will not be having visibility to what you are running inside that VPC. So that applies to RDS also. Whatever databases you are running is not visible to any third parties. So RDS instances is the underlying building blocks. Next is the security part of it. It carries forward. In addition to the VPC security aspect of it, you have multiple other things. Some of those things are listed here. Like I spoke about IAM policies for accessing your RDS database. Encryption is possible. You can also have a secure socket connections. That is SSL support is also there. And then you and encrypt your access using the security features of your database itself. There are each and every database engine like Oracle, MySQL, or MS SQL has their own parameters to fine tune the security. So you can use those parameters also to increase the security of your RDS instance. So while we are doing the demo, I'll show you how to use these parameter groups and customize those parameter groups and enhance the security of our RDS instance. So finally, there are a couple of more items before we see what else RDS can do. There are some concepts called automated backups and manual backups. One is you configure it and choose the retention period when you want to take your database offline or online backup. So you configure that using the dashboard, and Amazon automatically creates those backups and stores it in your snapshot section. So whenever you create a database for the very first time, Amazon immediately creates a snapshot of that database, and after that point onwards, it is an incremental snapshot. So the amount of data that is only changed is going to get a snapshot. So this way, your storage cost is also going to come down, and you can choose the retention period for your snapshots also, how long you want to retain that database. So say for example, you don't want your database to be stored for 90 days, then you set a retention period for something like 89 days. So on the 90th day, automatically your oldest snapshot will be deleted. So if you don't want that to happen, if you want to create a manual snapshot, you can also go ahead and trigger a manual snapshot. Has to be done manually. You have to go to the dashboard and decide whether you want to pause your database or stop your database before taking the snapshot. And then how long you want to delete it is absolutely yours. The retention policies will not apply to the manual snapshots. If you will have to manually go ahead and delete those snapshots. So there are multiple options for doing the backups in Amazon. So by using the retention policies, by automated lifecycle policies, and whether it is automatic or manual, whether you want to stop the database or not stop the database while taking the backup. So using a combination of these policies or concepts, you can configure the backup strategy for your customers. The another interesting thing about RDS is cross-region snapshots. Say, for example, you have created a demo database or a working POC configuration in the US region, and your manager or your client comes and says that, can you copy over this data to Asia Pacific region or an African region? So what you do is you go ahead and create a snapshot, and you can send the snapshot all the way across to a different region completely. you will incur data transfer charges, but it is just a few clicks away that you can move your database or the entire snapshot from one region to another region very easily. This way you can create consistent databases in different regions with minimal effort. Or that is one scenario. Another scenario is a backup and recovery scenario. You can constantly take backup and push it to another region, and then you can set up a disaster recovery in another region, so that if your primary site goes offline, you can create a disaster recovery site using this backup and then start your instances there. So usually what happens is people write CloudFormation templates or run some small sized instances in auto scaling, and whenever there is a more load, because whenever the DR automatically DNS will point it to a disaster recovery site, and that is Route 53. Once the more and more load comes into the small instance that you have configured into the DR site, auto scaling will start adding more and more instances, and your DR site slowly grows to become a primary site with the full capacity. And when your primary site falls back, the Route 53 will automatically, remember we did a health check in Route 53, the Route 53 will find out the primary site has come back online and start routing the traffic, and auto scaling will rebalance the traffic on the primary site itself. So that is how you set up that is how a concept of a disaster recovery works in AWS. Moving forward, a little bit more details on parameter groups and option groups. There are two different ways to configure or customize your database. So parameter groups used to customize your database engine itself. It comes from your database engine provider. It is whether it is Oracle or MySQL. Microsoft will provide what parameters you can customize. What are the fine tuning options that you have. Those are all the parameters. I mean, those are all the items in the parameter groups that you get. Whereas when it comes to option groups, it is the values that you get to manage your database itself. It is to ease the burden of managing the database itself. Since most of it is taken care at the database RDS itself, we don't have too many options in our option groups in RDS. Very limited ones, but you can customize them as well. So a small screenshot is shown where your option groups and parameter groups are visible, or when it is where it is available. Another interesting thing to note is in the bottom part of it is the pending reboot. If I can highlight it for you guys. So I'm talking about this one where the parameter groups is highlighted. There are some parameters that won't take into effect on the fly. It will need a downtime for your database to take into effect. To give an example, let us say you have started the database by default, and you find that the database is running on Indian Standard Time, for example, and your customer says that you don't want your database to be running on Indian Standard Time, and you want because all your customers are in the US region, and US has different time zones, so you want to change the time zone parameter of your database now. So you cannot change this parameter on the fly, because there might be multiple transactions dependent on time, especially payment or commercial transactions. You don't want the time zone to be changed on the fly, because that will impact when the transaction has happened, on which date the transaction has happened, and it might increase or decrease the financials of the company based on the date the transaction has happened. So when you change some parameters very critical like the time zone, you will need a reboot, or you want to change, you want to stop all the IO activity or application activity, and then reboot the server and then take into effect the new parameters. So whenever you change some parameter like that and which requires a reboot, you will get a notification like this. As you can see on the screen, it will say that the new parameters have not taken into effect and it requires a pending reboot to come into effect. So you need to know this, because sometimes people try to change these parameters and say that it is not taken into effect, and why it is needs a reboot or some cases also. So that is the reason. There are multiple other parameters. I just gave one example. There are a lot of parameters for each databases. So you need to Google it, or if you're based on your skill or experience, you need to find out whether that parameter is going to require a reboot or not, and then apply it. So there are a couple of architectures. I'm just going to show you how RDS fits in. This is a very simplest of architectures. You have load balancer at the top of it, and then you have two application instances in the middle layer. So the load balancer is distributing this traffic, and whereas this application is contacting your master database at the bottom. And we have configured snapshots, so the snapshots are being sent to your S3 bucket. So this is how a typical two-tier architecture would look like. Let us say this is a web app servers, so it also runs the web servers also. So this is how a typical simplest sample application architecture which connects to your database looks like. But if I go ahead and want a multi-AC availability, because the current architecture doesn't have any resiliency built into it. If my master server goes offline, entire database goes offline. My application servers are not able to reach the database. So if I want to have a resiliency for an AC failure, I need to go ahead and deploy my RDS as a multi-AC deployment. So what I will do is, in one availability zone, I will create my master server. That is, as you can see here, it is here. And I will go ahead and say, in my next availability zone, create a slave server also. I can choose which availability zone that needs to be. If my region has multiple availability zones, I have that option. If we are like on a Mumbai region, you don't have too many options. You have only two availability zones. So one has to be for master and one has to be for slave. And data between this master and slave is automatically synchronized by Amazon itself. You don't have to do anything. It is synchronously copied. That is, all the data changes that happens in the master gets copied to your slave in a synchronous way. And whenever some failure happens to your master, for some reason your master is unavailable, then Amazon automatically promotes your slave to master. This will become the master automatically. You don't have to do anything. Your applications will not notice any changes, and automatically this will be promoted, and another slave will be created in the old region as soon as another slave will be created in the other availability zone. If there is a region availability zone level failure, then the slave will not be created. You will have to wait for another slave to be created after some time. So until then, your master will be working from here. And if a slave gets created, automatically the synchronous copy also takes into effect, and you can fail over any point of time saying, I don't want to run it in 1B, I always want to run it in 1A. Then you can move from master to slave again also. And when it comes to upgrades, if you, let us say, you are running version 1.0 of a particular database and your database vendor has released version 2, and you want the upgrade to be happen because there are some new features and you want to take into effect those new features or take advantage of those new features. So what happens is, you give Amazon the downtime that is required to do the upgrade. And what Amazon does is, Amazon upgrades your slave version first. And once everything is successful and they are happy with the upgrade, then they turn the slave into a master, and then they start upgrading your current slave server. So this way your clients are not having any downtime per se. Only your slave is going to get upgraded first, and only when it's successful, all the traffic is being routed here. So this way your downtime is almost minimal or negligible, and your upgrades are also happened in a smoother way without disturbing your service availability. So that is how your multi-AC looks like, or the features of multi-ACs are. So in application architecture level, this is how it looks like. You have your multiple application servers, the typical load balancer in front of it, and they talk to your master, and master in turn talks to your slave server in a multi-AC deployment, and you have snapshots also configured. So the simple difference is, you have an additional database which has a synchronous copy of your master also. So that is all I have for relational database in terms of RDS. We are going to spend some time on DynamoDB now, and we're going to see how DynamoDB is important, what are all the different parameters that is important for DynamoDB. So as I said in the beginning, DynamoDB falls into the NoSQL category. That is, it is a non-relational database, and it is always on SSD disks only. When you compare it with RDS can be on spinning magnetic disks, but DynamoDB is always on SSD disks. So the performance is always predictable, and it is very easy to scale the performance of a DynamoDB, because It is a no relation database. There is no relation between one collection and another collection or the records that are stored here. So it very easily scales horizontally. You can just copy over the data to another server and it keeps on scaling very smoothly. You don't have to worry about the scaling part at all. And as I said, SSDs, so provisioned IOPS is very easy. You can configure the amount of IOPS you want, the amount of read-write transactions you want. There are multiple ways to define the performance of your DynamoDB, and you can have predictable performance of your DB here. Some more features of DynamoDB, it is fully managed. You don't have to do the underlying engine. You don't have to configure backups or snapshots. It is by default has those provisions enabled, very much like RDS. It can handle any amount of data because it once again it underlying leverages the S3 storage. So you have handle any amount of data. It just keeps scaling automatically. You don't have to worry about it, and it is I mean, when you are comparing SSD based NoSQL databases, it is cost effective, but there are other some third party vendors who are comparing DynamoDB with magnetic based NoSQL storage. If you compare SSD and magnetic disk, there's a huge amount of cost difference. So at that point of time, it won't seem like a cost effective option. But if you compare like for like, that is SSD based NoSQL to SSD based NoSQL DynamoDB, then DynamoDB comes at the top because most of the management activities has been taken care. So to give a simple comparison, if you MongoDB also is available in the market as a database as a service, but when you compare MongoDB with the DynamoDB, the scalability of Amazon and durability of Amazon and management activities is completely taken off your hand. Whereas if you go with MongoDB, you'll have to do some of those tasks yourself. So cost effective it is from the perspective. If your client is asking, can you compare MongoDB and DynamoDB? So you should be able to go ahead and explain to them some of the features like durability and high availability is not there in MongoDB because it is built on top of S3 and you can keep on adding any amount of data that you want in DynamoDB. And likewise, you have the management aspects of it. So you speak about those aspects. I wouldn't really say that it is the most cost effective solution, but if you want a hands-off solution, this is the one that you want to go with. So here's a nice and quick table summary of SQL, NoSQL to make your understanding better. When you are talking about data storage, data is stored in SQL as rows and columns, whereas here it is stored in a key and value. So when I say row and column, if I can draw your attention to the bottom, so each row here is having an ISBN value, title for the author. We are talking about a table for books. So one book here is about cloud computing concepts, and it has the author name Wilson and paperback, and another row for a different book will look like this. Whereas NoSQL, it will look like this. It is a JSON collection or a dictionary object. So it is called as a collection. This entire code snippet is called a collection. So each record or each collection will be stored separately. There will be no relation between each of them. So that is how NoSQL stores it, and it will have just a point reference saying collection number 1, and this will be collection number 2. So that it will be the only reference key value, and that is how they will be identified and enumerated. So schemas, you have a very fixed schema here because you need to fit everything into the title, author, and format, and this is the values that you can enter. But when it comes to NoSQL, you can have suddenly here whether you are lent it to somebody, your friends, whether it is transferable or whether it is a soft copy. You can keep on adding any of the values dynamically. There is no hard and fast rule of what values you need to have here. So that is why it says dynamic here. And if it comes to querying, you have to use an SQL based query language to query the data. You have to say where title equal to cloud computing concepts, get me the author name. You can do queries like that. Whereas when it comes to NoSQL, the query is based on collections. You get this entire collection, and again you go ahead and query within this collection what is my keys. And for example, key is format here. and what is the value of the format key, then you get the answer paperback. So it is very dynamic for NoSQL. It depends upon the type of collections that you store, and you need to understand what is inside your collections, or you need to iterate through a for loop. You go through all the collections and find out, I mean, all the keys in the collection and find out what is the value for those keys. So that is how you get the value of your NoSQL collections. Finally, as I kept remember, if I spoke about scalability, this is only vertically scalable. If you want horizontal scalability, you need to have only slave copies or read replicas. Whereas when it is NoSQL, you can horizontally scale it. It's just a collection. You just can copy it any number of times to any number of databases, and you keep on adding to that also. So it is very easy to scale horizontally NoSQL databases. That is why some of the modern day companies like Facebook and Twitter, these kind of companies use Cassandra DB, or in other words, a NoSQL engine predominantly. In fact, Netflix uses the Cassandra DB very well, and they have optimized Cassandra to the next level. If you didn't know, Cassandra is a NoSQL columnar database. Go ahead and Google it. It's a very nice articles those guys have written on Cassandra. Moving forward, some of the use cases where they are used. When it comes to application type, if you have a database or a business process centric application, it is better to go with RDS. If you have a large web scale application like Facebook or Twitter, or I would say sometimes Netflix falls in this category, web scale, because you can stream anything from your application browser. So NoSQL makes sense in that case. If you have a small read rates like Twitter, NoSQL makes fantastic sense here, because think of it, everybody is writing 140 characters into your database and fetching 140 characters at any point in time. So there is a lot of small read rates happening in your database like Twitter. Then NoSQL makes fantastic sense in that case. And for application characteristics, depending upon your data model, if you are going to run complex join queries in the sense you have multiple tables like a student, a mark sheet, a school, college, and you want to link all these tables and get some values. Where the student has studied, what is the average marks that he has scored in school, college, and university or post graduation. So you are going to combine multiple tables, and from multiple tables you are going to get the marks column, and you are going to aggregate that value. So if you want to run, that is not exactly complex, but there are more complex queries available. Just give an example, those kind of complex queries you want to run, then RDS is your best use case. You cannot run those kind of complex queries in NoSQL, because the performance is not so good when you try to run complex join queries. It is not at all possible. I mean, it is not at all performance wise. It's not good to run that kind of join queries on NoSQL database. Scaling, we already talked about it. One is vertical scaling, and if you want to do horizontal scaling, then you need to do partitions and sharding. Those are all database concepts. Partitions split the tables into either multiple, like older data can be partitioned and kept it in a different database, and latest data can be kept in a different database. That is how partitions and the concepts is. Sharding can be horizontal or vertical. You can have particular columns into a different database itself. That is what sharding concept is. Depends upon your DBA architecture. You can use the appropriate concept. You can have a rack kind of cluster also configured. That is how RDS works. Our relational database works. When it comes to NoSQL, it scales on demand. You don't have to worry about it, because it's a collections. You start writing to another database to scale, or another instance to scale. Quality of service depends upon what you are querying. If it can be automatically scaled, so your quality of service is not going to be degraded when the amount of IO increases in NoSQL. When it comes to SQL part of it, you need to do a lot of performance tuning to get the necessary performance. If you write inefficient queries, sometimes it is easy to take all the values in a table into your memory and try to query them. But that might not be the most efficient way of querying it. There might be some primary keys or secondary keys. Say, for example, in the student example we spoke about, every student might have a roll number or a serial number or some identifier number. So if you go and query only for that value and then pick up the mark sheets in another database from university, school, and kindergarten, everything, then it is more easy and efficient to have a better quality because your query is more optimized now. So query optimization is important and indexing is important, so that indexing is a student ID or creating a hash index or a map index. So you create those kind of indexes, then your performance increases and your quality of service also increases. But when it comes to DynamoDB, the whole concept is completely different because the performance is going to be through provisioned throughput. You can have a read capacity or you can have a write capacity defined. You can say that my read capacity needs to be 4 KB and provide me consistently 4 KB of read of from today onwards. Or when you say that when I want write capacity, minimum is 1 KB. It's not large as 1 KB. You can have go higher than that. So for one second, one write per second for items as large as 1 KB. So you can configure it as in units. So how many units of 1 KB you want, you can define that. So 1 unit equal to, let us say, 1 write per second for an object as large as 1 KB. So if you say 10 units, you will be provisioned with a capacity of 10 KB there. So this way you can decide how much of throughput you want for your database, and you can configure it when you're setting up your DynamoDB. We will see that more in detail how we set it up in a demo. It is more easy to see it in the demo itself. So moving forward, it's a data model, just a pictorial representation of how a collection looks like. Here the example is in music. You are going to store different music items. Say each on the left hand side, on the right hand side, you have the items. So this one is a collection now. This it looks like a row so that it easier to understand. But if you can see here, this row has only 4 items, or this one has 4 items, whereas this one has 5 items. So each collection can have a different kind of key value pair. There is no necessity of my collection has to have only 4 items. It always needs to have 4 items. So if you can see, this one has only 3 items. So you can have various attributes as or key value pair or name value pairs. The first one has artist, title, song, and album. This one has year also, whereas the second collection or second item doesn't have year at all. So that is how a data model for an NoSQL database looks like in comparison to a SQL database or a row and column database. So if I move forward for primary keys, if people familiar with the database, they will know that SQL databases will have a primary keys. So here also you can have something called as a partition key. So using this partition key, I will be able to identify my items uniquely. You have to define what is going to be your partition key in your data model so that you can query faster in your collections. So it is possible to identify one particular key which will always be present in my collection, and if that identifier is not there, the collection will not be accepted and it will be rejected. So in this case, for a music, artist is the most important attribute because almost all of the songs is created by some artist, and so I'm going to define my artist as my partition key here. And it is also possible to create a sort key also. By writing the database, I'm going to say I sort my collections based on a particular item in my collection. So here in this case, I'm going to sort it by title song or song title, in other words. So finally, I can have one more identifier. So you can have another identifier both for index as well as for keys also. So in this case, I'm sorting it by title and then song title, and you can also go with album title also. It is also possible for creating one more key, which is the secondary index, and my secondary index will also be sorted. So when you're querying all the databases, then you will try to find out using the partition key, find out who sung this song. Let us say A.R. Rahman is the artist for a particular song, and list out all his songs based on title. And then you have album title also. If he has released his songs in particular albums, then sort them by album title first and then by song title. So you can have any kind of a sorting built into your data model directly. So this is a simple explanation or understanding of how the DynamoDB collection looks like and how you can use partition keys, sort keys, and LSI. So these three parameters are available in your DynamoDB dashboard. So you can use them effectively to query your data that is stored in DynamoDBs. So go ahead and make your understanding a little bit clear. Here, let us look at the application architecture for DynamoDB. Here, there is no master or slave. It is straightforward. You have your application running in auto scaling group here, and you have your load balancers, and you are getting load from your mobile devices or your desktop client devices. And here in the backend, you have your DynamoDB. It is transparent. You don't know whether it is master or slave or how many copies are there, because if you remember, it is horizontally scalable. So that is, and we n number of instances. That is why your performance is defined as a throughput in terms of read and write KBs. As and when the more requests are coming in from your application, you will be redirected to the appropriate storage that has your data. Or if you are going to write it, because the write is also spread across multiple locations within that region, so it is going to be redirected to the appropriate place where it will give you the best performance for you. So it is completely transparent or hidden from you the operational aspects of the DynamoDB. You cannot see what is on the back end. So this is an overall design considerations. It is not specific to NoSQL. It is overall for SQL as well as NoSQL. One size does not fit all, meaning that don't try to think that your previous project had this database engine, Oracle database engine. It always works good for my new client also. Your new client might need a NoSQL database. So think about it, what type of database or what type of querying or what type of application they are running. So choose your database engine appropriately and the service also appropriately. And while choosing, you need to define look at these all the parameters. You need to see what is the data format. Are they going to store it in a binary format? Are they going to store it in CSV format? What is the size of data? How often they are going to query the data? Am I going to query it every day, or am I going to query it every month? Or it is just for storage purpose, you are just storing it there in a database? And how often you are going to access it and how fast you are going to access it. So that is going to define what is the performance level you are going to define here. And finally, retention period. If you're going to store it for compliance purposes and only one time you're going to store it and you're not going to retrieve for the next 7 years or 10 years, so you decide your database appropriately. Probably you can just store it in S3 itself. You don't need a database itself. So talk to your client, understand these parameters, then tell them what is the database they want to use. A summary of all those things. If you need a relational database with minimum administration cost, so go ahead with MySQL, MariaDB, MS SQL, or anything, or in other words, RDS would be a best fit. But if you want a very highly scalable NoSQL database engine, then DynamoDB is your best choice. But if you want to have full control over your database, that is, you want to customize where your database is residing, what is the performance level, you want to customize more parameters, you want to have more metrics of your database, then this managed database that is provided here will not be working out for you. You go ahead and start your go ahead and start your AMI in Amazon EC2 and install your database engine on top of it and then start running it. Or in other words, if you have a license, very strict license, which ensures that you want to run only in 2 CPU and then 4 GB of RAM, then you, because RDS is a shared service and your CPU and performance metrics goes up and down, you can change it dynamically. Some some database engines will not allow you to run it on a shared machine, or where the performance can be increased dynamically, or where it is not easy to measure the CPU usage. Those restrictive licenses are there in the market. When you are in that case, go ahead and launch your EC2 and put your database on top of those EC2 instances itself. So these are different considerations. Depending upon your use case, you need to recommend the appropriate one to your customers. So I'm going to stop here. Elasticache is in-memory database. Sometimes what happens is you want to cache some of your data to your memory itself. There are two types of memory caches available in the market. One is called Redis, another one is called Memcache. I'm talking about these two. Uh, Both of them have their own merits and demerits. Depending upon the application, the choice of memory or in-memory database will be chosen. Both of them have their own clusters, Redis cluster or Memcache clusters. So you would have to speak to your application team and ask them what is the data model, what is the querying model, and based on that only the choice of Redis or Memcache will be decided. So this is not a decision that an AWS engineer or consultant will make directly. It will be in consultation with your client, your application team, and your data model architecture or a data architect team. And then based on that, you will choose your Memcache. Basically, this sits in between your application and your database. So any query that can be quickly answered by your in-memory database will be sent to your Elasticache, Redis, or Memcache. And if that cluster or your cached data is not enough to answer that query, that is when it gets forwarded to your database itself. Basically, it is to improve the performance of your application or your response time of your application so that your database is not flooded with queries that can be easily answered by another cached layer. So that is where Elasticache or Memcache comes into the picture. So there's a demo. After this, we'll go ahead and see how to set up an RDS instance and what are the various options that is available in our RDS instance. I'll pause here for a minute to reflect upon what we have done so far. Thank you for listening so much time.